All right, welcome to part 3 under code. All right, and in this part 3, we will consider the last and critical, crucial aspect of a code that we call frustum of a code. Frustum of a code. This is going to be the last aspect under code. All right, are you ready? Are you ready? Beautiful. All right, if you cut the top, if you cut off the top of a cone, let's assume that we have a cone like this. Of course, this is our cone. This is our cone. If you decide to cut off this side, you cut it off here. What do you call the shape that is left? So if I cut off this one away, the one above here, if I cut it away, I'm going to be left with something like this, right? Can you see? Do you know that this shape left here, what do you call it? It is called Frustum. It is called what? Frustum. It is called what? Frustum. All right. The one up here is called, this one here is called the smaller cone. It's called the what? Smaller cone. It's called the smaller cone. The smaller cone. While this one here is called the what? The frustum. So it is this frustum that we want to work on now. We want to establish some concept and exam pattern. So I would like you to pay attention. All right, let's take it again. Let's take the diagram again. So before I cut the code, I have something like this. Before I cut the code, I have something like this. All right, so this is the vertical height of the cone. This is the radius of the cone. This is O, A, B, and this is what? M. And in the last class, we have established that let this place be the height of the cone, and this will be the slant height of the cone, and here should be the radius of the cone. Now, this is the main cone, right? Now, when it was now cut, if you now cut it like this, we now said it will form something like this. We're going to have a smaller cone up here where we cut it, and we are going to have this shape here. Now, this shape here is what we call Frustum. This one, and this is what we want to deal with today. This one here. So get ready, get your writing material ready. So coming back to the diagram here, on the left hand side here, this diagram here, the one I put in the curly bracket here, this is the bigger cone, this is the full cone. So I'm going to be using capital letter to represent all the dimension here. So this here becomes capital letter L, while this one becomes capital letter H because this is the full cone, while the radius here becomes the capital letter R before we cut the cone. So when we cut the cone off, the part of the cone off here, we now have a smaller cone plus the frustum. Now the smaller cone here, let's call this place small letter L, small letter H, and small letter R. Of course, we're going to have a radius here. It's the same radius as the one above up here. Now this line is actually the depth of the frustum, or you can call it the height of the frustum. While here can be, this is the bigger R. Don't forget this is the big R. All right, there's something that I want us to note there. When we are talking about frustum of a cone, now you can see that the frustum of a cone is the resulting shape after we have cut a part of a cone out. So here we have two cones. We have the smaller cone, pay attention, which is this one here, and we have the bigger cone. We have the bigger cone. So this is the concept we are going to be using. So it means that if I remove the area of the smaller cone from the bigger cone, what I'm going to have left here is called frustum. Please take notes. That's what we call frustum. Example of frustum. Frustum is around us everywhere. Our bucket at home, the bucket that we used to bath at home is a what? It's a frustum. The bucket, some paints that we used to buy are in form of a what? In form of a frustum. Frustum is everywhere around us. All right. So without wasting time, so we can see that there are a lot of parameters here. Number one, note that we have Now let me draw the smaller cone out. Let this one represent the smaller cone, and let this one represent the bigger cone. So I have the bigger cone here. Please take note. So let's call this one O, A, B, and let's call this one O, C, D. If this is M, let's call this place N. All right. So, and then we have our frustum here. We have our frustum down here. This is our frustum here. All right. Now, for exam's sake, this is the diagram that will be given to us. And in the diagram, of course, we are going to be given the radius of the top circle and the radius of the bottom circle. Now, the reason why I am using small r and big R is that this small r is going to represent. So let's get the lesson started now. Small r is going to be radius of the smaller cone, radius of smaller cone. Take notes. So you must be able to differentiate between the radius of the smaller cone. Big R is radius of the bigger cone. So take note, radius of the bigger cone. Okay, what other things you need to know? You need to note your small l. Your small l is the slant height, of the smaller cone, while the big L is equals to slant height of the bigger cone. Take note, slant height of the bigger cone. All right, so we move on to small h. Small h is the vertical height, or the height of the smaller cone. Take note, the vertical height. So what we are dealing with is smaller cone and the bigger cone. So take note of the smaller cone, while the capital letter H is the vertical height of the bigger cone. Yeah, of the bigger cone. So I'll be establishing a lot of information here, and x is the depth of the cone, of the frustum rather, depth of the prism, of the frustum. What am I saying? Prism. Depth of the frustum. All right, so this is what you should note. So we should note that R is small r, big R, small l, big L. Now let me quickly show you something here, something very beautiful now. So here is a cone, and here is a smaller cone. Pay attention. We have said here is going to be x, and we have said here should be small r, here should be small h, and here should be small l. Now we said from here to down here should be what? Big L. We said here should be big R, right? Now, what do you notice here? The full height of that cone, which is the capital H, you can get that by adding the smaller height here, and the what? The depth of that cone. So you add them together, it's going to give you the height of the bigger cone. All right, so let's start developing the formula for them now. All right, so if I remove the smaller triangle, if I remove out the smaller triangle, let's see what we are going to have. We're going to have something like this: small l, big R, small h. I think that triangle is triangle OAONB. All right, it's a right angle triangle. So, and I can relate it together by saying that by using Pythagoras theorem. If I use Pythagoras theorem, I'm going to connect, because you're going to make use of all these things to calculate a problem. So if I use Pythagoras theorem, I'm going to have L square is equals to small h square plus small r square. Then if I draw out the bigger triangle too, I think triangle O and I think it's D. You have the big L here, you have the big H here, and you have the big R here. So if I apply Pythagoras theorem 2, if I apply Pythagoras theorem, so I'm still going to have big L square is equals to big H square plus what? Big R square. All right. So now don't forget that when you want to link the smaller h, the smaller r, and the smaller l together, you're going to use small l, this equation 1. Then if you want to link the bigger one, use this one as equation 2. All right, you are doing well. Now, these two triangles here, we can apply what we call similar triangles to link them out. You can apply what we call similar triangle. Triangle O and B is similar. Some can say it's congruent. It's similar to triangle OMD. This triangle, this smaller triangle and this bigger triangle are actually similar. And by following similar triangle property, so we say the radius of the smaller cone divided by the radius of the bigger cone should give us the ratio of the height of the smaller cone to the ratio of the height of the what? Of the bigger cone. But we have said that big H is equals to small h plus x from above. So we can say small r divided by big R is equals to small h divided by small h plus x. If you want to calculate any problem under Frustum of a cone, if you don't understand this one that I just did here, ladies and gentlemen, you can't solve any problem under Frustum of a cone. So you must understand that small r divided by big R is equal to small h divided by small h plus x, which small h plus x is equals to capital letter H. All right, moving further now. Moving further. I want to move further now. Moving further, how do we now calculate surface area of a frustum? So we have something like this. Surface area of a frustum. All right, so if you are asked to calculate the curved surface area, now this is where the problem is. To calculate the curved surface area of a frustum, of a cone. To calculate the curved surface area of a frustum of a cone, you are going to say the curved surface area, curved surface area of bigger cone, that means the full cone, you are going to subtract curved surface area of the smaller cone. That's how you get the curved surface area of frustum of a cone. So it means that curved surface area of frustum of a cone is equals to, what is the curved surface area of the bigger cone? So the curved surface area of the bigger cone, from what we established before, is going to be pi big RL. Don't forget that pi RL is just this curved surface area of the cone. But because we are talking about the bigger cone, it's going to be use capital letter L and capital letter R minus curved surface area of the smaller cone by small r L. That's number one. Number two, if you're asked to calculate the volume of the frustum, volume of frustum, volume of frustum of a cone, I want to say volume of bigger cone minus volume of smaller cone. That's how you calculate the volume of a frustum. So by formula, the volume of a frustum, let me just use frustum cone. Yeah. Because the volume of the bigger cone is going to be 1 divided by 3 pi big R square big H minus 1 divided by 3 pi small r square small h. You have developed the formula for volume of a frustum of a cone. Then number 3, you may be asked to calculate total surface area. Take note, you may be asked to calculate the total surface area of a frustum of a cone. So this means that we are going to add all the surface area together. So let's draw the frustum here and let me show you how you do that. So this is the frustum. So what are the surface area of a frustum? We have top circle, we have bottom circle, and we have the curved surface here, the curved surface area here. So what I just need to do is to add everything together. So how do I add everything together? Very simple. So total surface area is equal to top circle is pi small r square plus bottom circle is pi big R square plus the curved surface area. So whatever answer you get for your curved surface area, you just put it there. Or just say pi R square plus pi under R square. Then plus this one is now going to be pi big RL minus pi small rl. So here I've been able to establish all the formula for total surface area of a frustum of a cone, curved surface area of a frustum of a cone. Now, in some special case, pay attention. In some special case, if we are to find the total surface area of a frustum, total surface area of a what? Of a frustum. Total surface area of a frustum. When one end is open, of course, you'll be told the end that is open. You'll be told the end that is open. Maybe it's the smaller, the one with the smaller radius that is open, or the one with the bigger radius. So, as the case may be, just say if the smaller end is open, the total surface area will now be pi r square, big R square, plus curved surface area, which is pi big RL minus pi small rl. That is if the smaller circle, if the smaller circle is open. If the smaller circle is open, I've seen this thing in exam before, so we will not add that one together. And also, total surface area of a frustum is equals to pi small r square plus the curved surface area. The curved surface area. This one is when the bigger circle is open. So these are the trickish exam question they can ask us. So they have been able to establish everything that we need to know under frustum of a code. So in part 4, I will be solving practical examples and WAEC and JAM question on frustum of a cone. So all these formulas are very, very important if we want to survive. Thank you. My name is Tutor Koko, and do well to share my video and follow my page for more educative content. Thank you. Bye.